Welcome to PRISCI-ANTO Educational Academy. Find the bilinear transformation that maps the point z is equal to 0, 1, infinity, and w is equal to I, 1, minus I, respectively. So the answer is the bilinear transformation or Mobius transformation. The formula is w minus w1 w2 minus w3 divided by w minus w3 w2 minus w1, which is equal to z minus z1 into z2 minus z3 divided by z minus z3 into z2 minus z1. So what is the z1, z2, z3? z1 is equal to 0, z2 is equal to 1, z3 is equal to infinity. w1 is equal to I, w2 is equal to 1, w3 is equal to minus I. So therefore, so you got to apply here. Before applying, which term is having infinity? So you got to watch it. Suppose if any one of the z1 or w1 is in infinity, so you got to rewrite the formula. So w minus the w1, w2 minus w3 divided by w minus w3, w2 minus w1, which is equal to, in z3 is having infinity. So that's why z minus z1, z3 you have to take as a common. So z2 divided by z3 minus 1 divided by z3 you have to take as a common, z by z3 minus 1, z2 minus z1. So therefore z3 cancel. Now you can apply the values. So if you apply the values, you will get, which is equal to w minus w1. w1 is I, w2 minus w3. So 1 minus w2 is 1 minus w2 minus w3. So w2 minus w3 is, so 1 minus of minus I, 1 plus I divided by w minus w3. So w plus I. w2 minus w1, 1 minus I, which is equal to z minus z1. z1 is 0. z2 by z3. z2 is 1. z3 is 1 by infinity minus 1 divided by z by z3. z by z3 is infinity minus 1. z2 minus z1. 1 minus 0. So every value we have applied. So therefore in the next step you have to write, which is equal to w minus I into w divided by w plus I into 1 plus I divided by 1 minus I, which is equal to, what is a z minus 0? z 1 by infinity 0. 0 minus 1 minus 1. So minus z divided by z by infinity 0. 0 minus 1 will be minus 1. So z is equal to w minus I divided by w plus I, 1 plus I divided by 1 minus I. You have to take the conjugate, divide and multiply by 1 plus I, which is equal to z. So if you are multiply, you will get 1 plus I, 1 plus I. 1 plus I whole square will be 1 plus I plus I minus 1. So divided by 1 minus I into 1 plus I will be 1 minus I square, which is equal to Z. So minus, this will be cancelled, I square minus 1. So therefore W minus I divided by W plus I plus I 2I divided by 1 minus of minus 1, which is equal to Z. So therefore which is equal to W minus I divided by W plus I 2I divided by 2, which is equal to Z. If you multiply IW, 2 cancel, so IW minus I square divided by W plus I, which is equal to Z. So in the next step you can write as IW, I square is minus 1, so plus 1, IW plus 1 divided by W plus I, which is equal to Z. So you have to do the cross multiplication. So IW plus 1, which is equal to Z into W plus I. So IW plus 1, which is equal to WZ plus ZI. Okay, so IW minus WZ, which is equal to this one, if it goes to right hand side, IZ minus 1. So therefore W you have to take as a common, I minus Z, which is equal to IZ minus 1. So W is equal to IZ minus 1 divided by I minus Z. This is the final answer.